Imagine you're lost in a massive city. You need to find the fastest route from your home to a friend's house across town. What do? The traditional approach, used by computers for over 60 years, is like sending out a search party from your home. They walk down every street, check every corner, spreading out in all directions, even streets that lead completely away from your friend's house. Eventually, they find it. But they've wasted a lot of time exploring places they never needed to go. This is exactly how the classic Dijkstra algorithm works, created in 19... But it has a fundamental flaw. It searches blindly. It doesn't know where the destination is, so it explores everything equally. On a map with 10,000 locations, it might check 8,000 of them just to find one route. Now, what if we tried something different? What if we sent two search parties, one from your home and one from your friend's house, both walking toward each other? This is the core idea behind our method. Watch the screen. On the left, you see the old way, one search expanding outward like a growing circle, covering massive ground. On the right, and look how much less ground we had to cover. Think of it like digging a tunnel through a mountain. The old way? Start from one side and dig all the way through. Our way? Start from both sides and meet in the middle. Same tunnel. Off the digging. But we didn't stop there. Our system also remembers. If you ask for directions to the coffee shop every morning, why should it recalculate the same route every single time? We store frequently used routes. The second time you ask. And it learns. The more you use it, the smarter it gets. It notices patterns, which places you visit often, which routes are popular, and it prepares for them in advance. The results speak for themselves. On small networks, we're 10 times faster than the traditional method. On larger networks, up to 50 times faster. And here's what matters. We never sacrifice accuracy. Every route we find is guaranteed to be the absolute shortest path. We're not estimating. We're not approximating. We're mathematically certain. What does this mean? For social networks, instantly finding connections between people, degrees of separation, friend recommendations. For delivery companies, optimizing thousands of routes in seconds instead of minutes. For video games, characters that find their way through complex worlds without lag. For 60 years, we've accepted that finding the shortest path takes time. That searching means exploring everything. We challenge that assumption. By searching smarter, not harder, by meeting in the middle instead of going all the way around, we've made the fundamental algorithm of the internet 50 times faster. It's free to use, ready to make your applications faster. Traditional Dijkstra searches from only one side, explores roughly 80% of the map, never learns from previous queries, and serves as our baseline for speed, while still delivering 100% accuracy. Turbo Dijkstra, in contrast, searches from both sides simultaneously, explores only about 20% of the map, gets smarter with every query it processes, runs 10 to 50 times faster, and maintains that same 100% accuracy. Same correct answer.